Good evening. Thank you so much for being here on such a wonderful day. It's much better outside, I know, but thank you. So, the title of the lecture is Tsunamis in Alaska, Are We Ready for the Next Big One? And as an introduction, I placed two photos here. One is from Kodiak, Alaska in 1964, from the Great Alaska Earthquake. And this is Ishinomaki City in Japan in 2011. You can see how very similar those photos look. And since it's a natural disaster, the Mother Nature is not aware of our technological advances. It doesn't know how well we are prepared for, technology and, cell phones and everything. So it will happen again, and it will be the same photo 50 years from now, 100 years from now. So that's why preparedness is the key, and there are many other aspects in tsunami preparedness that I'm going to talk about today. Oh. Could you click on that? Thank you. So, oops, we need to go through that, guys. So, yeah, let's try to do that. So, can you tell me which are not tsunami sources for sure? If you see something, say so. And the hint is there are 3 of them. Only 3 of them are not tsunami sources. Okay, I'm listening. 3, great. It's tornado, right? Tornado is on land. It doesn't make tsunamis. So, what else? 5 is questionable. I will talk about that later. 5 is tricky. Okay, what else? 7, great. It's a submarine. Submarine doesn't make tsunamis, yes. So what else? One more. 3, 7, and yeah, look at 9. Is an earthquake on land. Earthquakes that on land don't make tsunamis. To make a tsunami, you need to be underwater. So this particular earthquake offshore Kodiak in the Gulf of Alaska, yes, it will make a tsunami. The meteorite dropping in the middle of the Pacific will make a tsunami. Tornado, no. What is 4? 4 is underwater landslide. Yeah, if you have an underwater landslide, you will have a tsunami, and this is one of the major hazards in Alaska, underwater landslides. This is very interesting thing. This is a storm moving over huge areas of ocean. And this atmospheric forcing can generate a tsunami wave. And this is exactly what happened recently with the Tonga eruption, when that huge atmospheric wave generated a tsunami. And that tsunami arrived before the real tsunami that happened because of the collapse of the volcano into the ocean. So it's a different type of forcing. It's called Meteor Tsunamis. They don't happen in Alaska, but they do happen in the Gulf of Mexico, in Mediterranean Sea. So this is the way people observe them and study them. There are conferences on Meteor Tsunamis happening in beautiful places like Mediterranean, Santorini, Crete, Mallorca, and so on. So then volcanic eruption in the middle of the ocean, of course, it can make a tsunami. Submarine, no. Landslide, that is subaerial landslide, but it enters water, it pushes water, it can make a wave. And finally, earthquake on land doesn't make tsunamis. That's why when you hear about earthquake that happened somewhere, let's say in the interior Alaska, yes, it's not the case. I will start with the quote from the scientist who used to work at the National Tsunami Warning Center in Palmer. And tsunami can happen anytime, next month, tomorrow. There is a whole generation of people that have grown up without having seen anyone killed by a tsunami, without having to pull dead bodies out of bushes around here, without seeing 80-foot boats that have gone through their living rooms. People tend to forget. And this is one of the major challenges in tsunami preparedness. People forget about disasters. It's called disaster amnesia. And why it is a problem? I'll make you guess which nation is the most prepared for tsunamis here. I just put several tsunamis from a huge list of tsunamis because they have something interesting in common. Look at those 3 tsunamis in Indonesia. Look at the fatalities. This one was the largest number of fatalities before 2004 tsunami happened. And then Japan, of course, had big tsunamis in the past. But look at those 2 Alaska earthquakes that were huge earthquakes. But at the same time, the number of fatalities were quite low compared to others. But guess what? Both these events resulted in something really good. First of them resulted in establishment of Pacific Tsunami Warning Center, because before this, the tsunami warning system didn't exist in the United States. The second one resulted in the Alaska Regional Tsunami Warning System. Then the horrible disaster of 2004 happened, and now you can look at how many different tsunamis in Indonesia happened before. And then you think about those local children that ran to the shoreline when they saw the water receding. They had no idea what's going to happen next. And despite of all this history of tsunamis in the past, nobody told them, nobody transferred that knowledge from older generation to the new generation. And this was a shocking behavior of local residents who had no idea what's happening, despite of like very, very big history of tsunamis in the region. But in the United States, there was another lesson learned from this event. The Tsunami Warning and Education Act became public law, which means that it's a line item in the budget, and every year it's renewed. So that's why I'm still employed as a scientist doing tsunami mapping in Alaska. And then the shocking disaster of 2011 happened in the country that was most prepared for tsunamis. And I will talk about what kind of lessons we learned from this particular disaster. So I usually start from the end in case people fall asleep, so you know exactly what you have to take home from the lecture. So let's do this first. First of all, those 2 tsunami disasters of 21st century, the 2004 and 2011, they showed the entire world that the magnitude 9 earthquake has a global reach, and that tsunami is not any longer a concern of a country which it happens. People travel, people go to vacations. You know how many tourists from Sweden died in Thailand on December 26, 2004? 360 tourists from Sweden. This is a country in Northern Europe. They don't have tsunamis, they have nothing in terms of natural disasters, but they go to Thailand for vacation. And when those tourists saw the water going away, same thing. They went to check out what's happening and what's on the bottom of the ocean. And Alaska is the biggest tsunami producer in the United States. But unfortunately for us, that time that we have before tsunami strikes is pretty much, we are talking about minutes. And that's why knowing what to do in advance, instead of waiting for officials to tell you what to do, pretty much means difference between life and death. And finally, as I said before, tsunamis are pretty rare. And maybe it's not going to happen in our lifetime, maybe not in our children's lifetime, but you know, for sure it will happen in our grandchildren's lifetime. And that's why we need to pass our knowledge to younger generations, and educating children about tsunamis is the most important thing we can do here in Alaska in this kind of century. And why Alaska is the biggest tsunami producer? What is so special about Alaska? There are 2 major factors. First of all, it's the seismically active subduction zone. And we know that Pacific plate subducts underneath North America plate along the Aleutian volcanic arc. But also we have glacial fjords in Alaska. And glacial fjords bring those unstable sediments into the fjords from the glacier. Glacial creeks and rivers, you know, the color of those creeks and rivers, they're pretty, you know, murky. And this is the sediment that gets deposited on the steep underwater slopes. And when it shakes, they go down. And this is how tsunamis are made in coastal Alaska. But both of these factors result in what we call near-field tsunami hazard, which means we don't have a luxury of 2, 3, 5 hours for evacuation like people in Oregon, Washington, California, and Hawaii have. We have minutes. That's why we need to know exactly what to do at 4 a.m. when a tsunami siren starts, what to grab, not to think, oh, where is my foreign passport, by the way? Let's find it. No, it's not time to think about passport. So it needs to be prepared. You need to grab that thing with all the important stuff and go. And you need to know exactly where to go, where that shelter is. Let's look at the history. Everything started with the 1946, the tsunami warning system started with the 1946 earthquake that killed 159 people in Hilo, Hawaii, 5.5 hours after the earthquake, which was a tragedy because 5.5 hours, it's enough to do something, right? And in 1964 Great Alaska earthquake, 92% of all fatalities were due to tsunami waves. Only 8% died because of earthquake itself. And what's interesting is that 76% of them were due to local landslide tsunamis. So people in Alaska died from local landslide tsunamis in places like Seward, Valdez, Whittier. Now look at the Southeast Alaska. Lots of glacial fjords there. You probably know that the absolute world record of the highest wave ever recorded on Earth belongs to Alaska, Lituya Bay, 58, 524 meters wave, which is times 3, 1,500 feet, which is higher than Empire State Building. This is how we compare. It's pretty impossible to imagine, but there were people on the boat who survived that wave in Lituya Bay. The amazing fact is that in the same exact bay, those landslides happened before several times in the past. And the 36th one is also the 5th largest in our table of largest waves. We are not there yet. There is a 4th largest that happened in 2015 in Tanfjord here in Southeast Alaska. And finally, you probably heard about Berry Arm, a recently discovered unstable slope in Prince William Sound that is sitting there. Huge amount of material can drop into the water. It will be much larger than the Lituya Bay. To compare the volume, the Lituya Bay slide was about 63 million cubic yards, and the Berry Arm is 600 million. So pretty much 10 times larger than the Lituya Bay. So why, a little bit of a history, why I chose to study tsunami waves? First of all, because something can be done about it. We cannot predict earthquakes, but tsunamis, once a tsunami is generated, can be forecast, and we can predict exactly when it arrives to different places around the coastline, and we can predict the impact. And the magic is all about modeling. We can model that, and it's very good precision of that modeling. And this is the device that allows us to record tsunamis in the open ocean. And I'll talk about that later. And then, because of that, we can save lives. It's not like we are helpless, right? We can detect it in the middle of the ocean while it's still propagating, and when it hits land, people know about that. People are prepared, unless they decide to do the opposite. For example, in Crescent City, California, people were told, please don't go to the harbor. Tsunami is coming from Japan. Guess what? People go to the harbor to watch the tsunami coming from Japan. So this is where you have to choose. One person died, by the way, there. But there were other reasons, a little bit not that glamorous. So one of them is that it's pretty easy to visualize. Tsunami waves are easy to visualize compared to other types of waves. I had a choice of studying like acoustic waves, plasma waves, electromagnetic waves. Hard to visualize. I decided to go with ocean waves. And another reason is, believe me, relatively simple math equations compared to other waves. Relatively simple. And because of that simplicity, we can predict where and when tsunami hits the coasts. This is the beauty of it, why we can do that. So what is a tsunami? What does it mean? It's a Japanese word that has two characters. And it's Tsu, which is harbor, and Nami, which is wave. And it doesn't sound kind of intuitive, right? Because when we think about tsunamis, we think about a wall of water coming from the ocean and kind of crashing everything. Why harbor wave? It's because in Japan, in old centuries, when a fisherman would go out of the sea to fish for a day in deep water on a beautiful sunny day, and then he comes home and he finds that in the harbor, total destruction, and they had no idea what happened exactly, because in the open ocean they didn't feel anything. It was nice and sunny and beautiful, calm waters. And this is the thing, tsunamis are invisible in deep water, and we will talk about that. They come home, they see that, and they thought logically that something happened inside the harbor, right? And this is why they called it harbor wave, because this is where tsunami manifested itself, in a harbor. And now the most important slide, and you pay attention, because later I will be asking questions, like there will be several whys. And this is the answer. Like in this slide, all the answers are here. So pay attention. First of all, tsunami is a very long wave. But by long, we mean the distance between two crests. In the open ocean, it's about 60 miles. But at the same time, that height of the crest is about 1 foot. Now imagine one crest to the left, one crest to the right, and between them 60 miles, and you are sitting here. Can you see that wave? It's impossible. It's pretty much flat, right? You can see the difference of 1 foot on the distance of 60 miles. It's impossible. And the depth of the ocean is 3 miles. And by long wave, we also mean that the distance between the crests is much larger than the ocean depth. So 60 miles versus 3 miles. Pretty much the entire ocean, it's like boom, 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 like this. And then the second important property is this one, that the speed of the tsunami only depends on the ocean depth, right? And this is exactly what it means. The deeper the water, the faster the wave, right? So square root of gravity times depth. Gravity is a constant, right? Depth is whatever we have on the ocean depth. So basically, when it's deep, it travels faster. When it's shallow, it slows down. Remember. Okay. So facts about tsunamis. And, I called them interesting before, not anymore. Because if you know that, you will be making right decisions. And these decisions will save your life. And I have examples of how it works. First of all, tsunami is not just one wave. It's not in and out. It's a series of waves. And this is what people don't realize. Then they go to the harbor, see the first wave, it goes away, then the next wave comes, and it's much larger than the first one. And people get killed because they don't know that it can last for hours. For example, in 1964, in Valdez, the largest wave came 11 hours after the earthquake. You know why? Because earthquake happened on extreme low tide. 11 hours, it was a high tide. But the waves kept coming with an interval of about 1 hour. And finally, one of the waves came on high tide. And this is what was the worst wave of the event. And of course, they can be made by volcanic eruptions, landslides, asteroids, many different causes. By now, I think everybody knows that tsunamis are not tidal waves. Tidal waves are gravitational, caused by gravitational forces between sun, moon, and earth. But believe me, we have many papers written like before '64 where tsunamis are called tidal waves, like science papers. I'm glad the terminology is now kind of established. And this is another important characteristic of tsunami wave. It's very different from wind waves that disturb only the surface of the ocean. People who dive, they know that if you have a kind of storm at the surface, if you dive deep enough, it will be quiet there. Tsunami don't work that way. They have the energy propagating all the way to the ocean bottom. And because of that, we can detect them in the middle of the ocean because of this property of tsunami waves. So tsunami has three major stages of life. So first we need to create a tsunami, let's say by underwater earthquake. We need to displace that huge amount of water. And then it starts propagating through the deep ocean. And finally it hits land. And this we call run-up or inundation. Just technical terms for flooding when it hits land. So this is the animation that shows you, like it's a cartoon, that shows you how a tsunami is made by underwater earthquake in a subduction zone, which is pretty much where we are right now. So this is the North America plate. Let's say it's one of the volcanoes in the oceans. And this is the Pacific plate goes underneath North American plate. Could you please click on that animation? So over the centuries, that motion, like several inches a year, and then finally the pressure is such that it can't hold it anymore. It pops up and moves that water up. And this is how the tsunami is made. And now it starts propagating away from that source and finally, gets into the old coastlines in the Pacific. What happens next? Imagine you are in the middle of the ocean on that boat, and tsunami is traveling underneath you at the speed of about 500 miles per hour, which is pretty much the speed of the Boeing 747, which means that exactly 5.5 hours it takes tsunami to travel from Aleutian Islands to Hawaii, as for us to fly from Anchorage to Honolulu, same time. But if you're on that boat and tsunami passes underneath, you don't notice it. You remember the distance between two crests is 60 miles, the crest is 1 foot high, nothing. I've talked to a Navy officer who was on a boat, on a Navy ship in the middle of the Pacific in 1957, when another huge earthquake happened in the Aleutian Islands, generated a big tsunami. And the captain got a signal because it was already after 1946, we already had the tsunami warning system in the United States. The captain said, "What do I do?" That guy had a geology degree. He said, "Nothing you do. Everything is fine. We don't need to do anything. Not for us to worry about." So useful to know. But then, silently, it went through the Pacific, and then it killed people in Hawaii, and this is Gila waterfront. So the question is, how do they manage to transport that huge amount of energy if you don't even feel them in the open ocean? Like how, why? And it's because for the same fact that the energy extends from the surface of the ocean all the way to the bottom. And this animation, could you click on that? This animation shows how that concept, it was pretty hard to illustrate, but let's see if you see that. It's the entire water column. You see that? So it's not just like, if this is the bottom and this is the surface, it's not this. It's like this kind of motion. So the entire ocean moves. Now I have this question for you. When we say wave propagates or wave travels, what exactly travels or what exactly propagates? Because if you are sitting here and the wave comes underneath, you just go up and down, right? You don't travel to Hawaii. I wish, but no. I mean, we just go up and down. What propagates in a wave, in a tsunami, do you think? Like, what exactly moves? When we say the wave travels, right? It's not the water that travels, something else travels, right? Energy. It's energy that travels, right? You can touch it, right? But it's there. And most importantly, it's conserved. It's not going anywhere. It's still there. That's why when it hits land, it's so powerful, because it is still there. And this property of tsunami wave, that energy reaches all the way to the bottom, allows us to detect them in the open ocean. So this is the map of so-called DART stations, D-A-R-T, that detect tsunami in the open ocean. And these are the owners of those stations. All the blue ones are United States. And you see several of them along the Aleutian arc. Guess what? We don't benefit from them if the earthquake happens here in Alaska, because it hits land before it hits those stations. That's why we need to be prepared, for exactly that reason. And this little fun video shows how they installed that bottom sensor and how it works. Could you click on that? So you have a ship, installation ship, they have a buoy, and then they drop that device. So this is the bottom pressure sensor that records the wave. Now you have an earthquake, and then the wave comes. It feels the wave, sends the signal to the buoy, and the buoy sends the signal to the satellite, and the satellite sends the signal to the tsunami warning centers. Tell me, what kind of wave this device sends to the buoy? What kind of wave is that, do you think? Unfortunately, no. The next one, yes. The next one is radio or electromagnetic. This is the radio wave. But what kind of wave is, which waves do submarines use to talk to each other? Yeah, acoustic waves. Yeah, I'm talking to you right now, you hear me. These are acoustic waves or sound waves. This is the disturbance that propagates like that. Because okay, we can go to the next, okay. So unfortunately, electromagnetic waves do not propagate in water. That's why if you decide to talk to your friend on a cell phone sitting on the bottom of the pool, no luck. Doesn't work. Sorry. You need to have some kind of device that submarine uses. So, and finally, it hits land, right? Like what happens here? First of all, it reaches shallow coastal waters, and the distance between two crests in the open ocean about 130 miles, and the ocean is deep, but now we have that wedge. We had the wedge, and it's really shallow. The first thing what happens to tsunami, it slows down. Why? Great, great. You remember the slide, right? The deeper the water, the faster the wave. It gets into shallow water, it slows down. Then the energy is still there. Now imagine that energy that was distributed in that depth. Now it's kind of locked into 30 feet wedge. What happens to energy? Energy is still there. It needs to go somewhere. It doesn't dissipate. So it goes up, right? That's why the wave height increases rapidly in the coastal area, and that's why it's so destructive now. So this is the cartoon that we made before 2004 tsunami. And at that point, we didn't have any real footage of tsunami flooding a coastal area, but we had to illustrate it somehow. And very often, first thing that you see, that water goes away. And this is exactly what it means when you see that. And that cartoon, could you please click on the animation? Mm-hmm. If you see something like that, maybe not so fast, maybe a little bit slower, but just a fast tide that goes like that on a perfect day, and it's not a time according to the tidal table, it's not the time for the extreme low tide, it means you have to run. This is what tourists in Thailand saw in 2004. But then now we have lots of footage, and this one is from Japan. And here, I mean, of course, it's horrible, right? But what I want to illustrate here, I want to have the teaching moment that tsunami hits land, it's not a wave any longer. It's just an ugly sea of debris that has cars and houses and that bulldozes everything that's in front of it. You cannot outrun it. You cannot drive away from that. It's just too late. Could you start it? So you can see like the ocean is out there, and this is the moving front. People die in tsunamis not because they can't swim. People die from wounds from being cut by wood, by glass, by metal, and being hit by floating cars. So this is how people die. It's not about swimming. It's not about kind of drowning in water. So pretty much nothing can be done here. You just have to evacuate. You need to make right decision at the right time. And look how fast that front moving. And those objects are like cars and houses in that front. And this is like agricultural greenhouses in Japan. That's why it was such a disaster in terms of food supply. You can't drive away. The speed is too high. What happened in Japan that tsunami hazard was underestimated. Nobody expected the tsunami that high. As a result, the tsunami hazard maps were inadequate. And this is one of the examples. In that town of Manami-Sanriku, this was the area that was flooded by a tsunami. But look at that place. It was a disaster management building. In that building, people were supposed to manage that disaster. And you can guess that they wouldn't build a disaster management building in a hazard zone. It was a safe zone according to their maps. And it was underestimated. In this location, there is another interesting structure that's called vertical tsunami evacuation. So in this, if you see that green sign, now they are being built in the United States, those vertical tsunami evacuation structures in places like Oregon, Washington, where they don't have high land anywhere close to the shore and you really have to evacuate somewhere. They built those vertical structures. So if you look at that white arrow here, it shows you the height of the seawall that was supposed to protect town from tsunamis. And the right arrow shows where actually the water stopped. I hope that people who went to the roof survived in that building, and this particular building actually worked as a vertical evacuation, so the water stopped here, so people survived. Many of them were destroyed during that tsunami in Japan. And this is another pretty, dramatic video, but again, the teaching moment here is that the water will be coming for a long time because it's a long way. If you remember, the distance of, between crests can be 100 miles, and it means that it will be coming like for an hour before it goes away. And this is exactly what it shows here. So this is the seawall. You will see how it will be overtopped in a moment. But this is not just the beginning of the video. That video is so long, I just cut a small section of it. That water was rising for a long time until that happened. And this was kind of the end of the story. Could you? So watch that wall here. So one car is already, on the other side. So this is the wall actually. So I guess those cars were parked on the other side of the wall, and this is. As I said, like it's a small section of the video, it will keep coming for a while. Yeah, people are filming from I guess the vertical evacuation structure in the port area. Yeah, pretty horrible stuff. And this is what we call the energy map. You remember that when we talk about tsunamis, it's not the water that travels, it's the energy that travels. And we know that the depth of the ocean determines where the tsunami goes, because the deeper the water, the faster the wave. That's why the energy pattern of the 2011 tsunamis looks so irregular, right? Look, it's not like a perfectly kind of perfect circles. It's very, very strange looking. And it's because the bottom of the Pacific, if you open Google Maps, right, and you click on satellite, you look at the bottom of the Pacific, you see all kinds of mountain chains and canyons and you name it, right? Like so many different features. And this is exactly what it shows. And sometimes you see very strange things happening. For example, do you know what this is? Like that place? Yeah, it's Crescent City. It's Crescent City, and look at that beam of energy. Like everything goes like southeast, and then all of a sudden, boom, that thing goes to Crescent City. Why? Because there is a mountain here that redirects the energy. the mountain chain that does that every time something coming from the west, Crescent City gets hit badly because of like combination of different factors. And you see what happened there. About 5,000 miles from the earthquake, about 10 hours after the earthquake, the wave height was about 8 feet, but currents were horrible in the harbor. The harbor was totally destroyed. It was a huge mess. And one person even died. 3 high school kids decided to go to the harbor to take pictures. And of course, everybody was told multiple times, please don't go to the harbor. Stay away. It will be dangerous. They go, one person dies. When I give lectures to high school kids, I ask them this question. How stupid do you need to be to die 10 hours after the earthquake that happened on a different side of the planet, right? Like in 10 hours, you can fly to Europe. You can fly anywhere. Why do you choose to go to harbor and die there, right? So like educational moment for children. This is another example of people who don't want to listen to authorities. So this is Santa Cruz, California, same exact event. And it's not even the first wave, it's the second wave. And lady here, listen to her talking. First of all, she is very proud that she was there watching the first wave. You know, of course, everybody was told, please don't go to the harbor. She is proud of that. And she says, we were right there, you know, for the first wave. And this second wave is pretty small. You will see the wave height here, just like that much. But see what it does and think why. Like this is my second why. Like think why it does what it does. Could you start that?
Wait, here it comes. Oh my God.
Yeah, they know exactly when the second wave comes, so they come and they watch it. So it's coming.
Yeah, we were right there.
She says we were right there. Yeah.
Oh my God.
And this is the wave. Look at this. This is that much. Right?
Oh my God. Okay. Oh, Jesus Christ.
Like why?
We're up on the floor. Oh my God. Hold that. There's nothing.
So if you have like a windstorm and the waves are 2 feet, it's nothing, right? They can do this. So this is done because, as I said, the energy goes all the way to the bottom. It's not just 2 feet at the surface, it's the entire water column moves like that. That little channel, the whole thing moves. That's why it's so destructive. Yeah. That's why it behaves so differently. So what were the lessons that we learned? First of all, in 2004 tsunami in the Indian Ocean, 230,000 people died, which was horrible because the system of tsunami warning didn't exist in the Indian Ocean. Scientists didn't realize that earthquake of that size could happen. And another horrible thing is that 300 people died in Somalia in Africa 7.5 hours after the earthquake. Again, in 7.5 hours, you can pretty much walk to the opposite coast of Africa, or you can fly to United States, or you can fly anywhere. You have time to evacuate, but if you don't know about the hazard, you are helpless, so you don't know what to do. And the response of local residents and tourists in 2004 was shocking. The images of children running to see what's on the shore and tourists, which means that the media totally failed to reach the public around the world. About 15 tsunamis that happened around the world since 1992, tsunami in Nicaragua. 15 tsunamis. I bet nobody ever heard about any tsunamis, before the Indian Ocean one. Yeah, the tsunami education didn't exist. There was one girl who saved the entire resort in Thailand because she learned about tsunamis in her science class. She was 11. She was from Great Britain, and she saw the water going away, and she says, "Mom, this is a tsunami." And Mom said, "What?" I said, Mom, talk to someone. And Mom, thanks to Mom, she talked to the manager and they evacuated the entire resort. She saved hundreds of people. She was invited to the United States and she met with President Clinton back then. So she was called the beach angel. And in Tohoku tsunami, about 20,000 people died. And in this case, the large amount of uplift of the seafloor was not expected. And as a result, the maps were not adequate and people had false sense of security and seawalls were not high enough. And my lesson is that it's a lesson in humility, that we don't know everything. Every time a new disaster happens, we will learn something else. And nature will keep surprising us. So that's why we need to be humble and we need to be prepared. We can say, oh, nothing like that can happen in our lifetime in Alaska. We don't know. I mean, those disasters show that we don't know so much that it's like mind-blowing. So, and okay, let's go to Alaska. The 1964 earthquake had a huge area of ground deformation. What is that? Like in the news, when they show you an earthquake, it's usually a dot, like vibrating, like red dot, like It's not a dot. The area of earthquake is huge, and this is where we call deformation, where some part of that land moves up, uplift, and some area moves down, subsidence. And it's always the case for subduction zone earthquakes. When you have one plate goes underneath another, when that happens, that motion up, you always will have uplift and subsidence. And people died in low 48 and in Alaska. And as I said, 92% of all fatalities were due to tsunamis. Ground was shaking for 4 minutes. It's pretty much impossible to imagine. 4 minutes with strong ground shaking when you can stand, it's horrible. So this is the animation that shows you how that 1964 tsunami propagated through the Pacific. And there are several interesting moments to look for here, at least 3. So one is where the energy goes, and the energy is represented by colors, like warm is high energy, cold colors like low energy. The speed in different parts, and like secondary sources of energy. Let's watch. Could you start it? It will run 3 times, and we can watch everything. So this is Hawaii. Look what happens when wave hit Hawaii. And look at the speed in the Pacific and also in Bering Sea. Okay, let's think about what we see. First of all, where did the energy go? Yeah, this way, right? Mostly this way. Then look at this. So the total time of tsunami travel here is 6 hours. I ran that model for 6 hours. So in 6 hours, it's already in Hawaii, but look at this. It's only halfway through Bering Sea. Why? Do you know? You know. Huh? Exactly. So it's very deep in the middle of the Pacific. It's very, you see that shelf, the continental shelf, when the wave hits that boundary, you see how it slows down immediately. It's like, that's it. It's like, because it's so shallow. And then Hawaii work as a kind of secondary source of energy. Look how they generate kind of secondary waves here. Okay. And this was the very first paper about tsunamis that I've read when I was a student in Russia, and it was written by Professor Kajiura, Japanese scientist. It's about tsunami energy. It's just called Energy of a Tsunami. And he showed, using mathematical formulas, that tsunami energy always goes perpendicular to the tsunami source. So if this is the initial source of the tsunami, it always goes perpendicular. Let's say if you have the earthquake here in the Aleutians, where would the tsunami energy go? It will go that way. We can just ignore the whole thing because nothing will get into Gulf of Alaska from there. It's a pretty good thing to know. But then when it gets closer to the coastline, look how complex the wave action is. I'm always asked questions in the coastal communities that, oh, if tsunami comes from there, we have that island there, and that island will protect us. Everything is determined by the shape of the ocean bottom. Unless you know exactly what's happening on your ocean bottom around your community, don't please assume that that island will protect you. Because you see that waterfront coming as a kind of very nice and straight line here, and that's what happens after. You see that beautiful line, and then it's a mess, because what's on the ocean floor determines where the tsunami will go, and which places it will hit hard, and which places will be saved from the impact. So this is another major hazard in Alaska, as I mentioned, slope failures. And there are two different types. We have underwater slope failures, and above water, we call them subaerial. And underwater could happen in fjords and also off the continental shelf, like in the deep water. And this is the Litui Bay slide, the dimensions of the Litui Bay slide. This is a very serious hazard in Alaska. This animation shows the mechanism of how a wave is made by underwater slide. Could you please click on that? Mm-hmm. So let's say somewhere on that slope we have a chunk of unstable glacial sediment, and when earthquake happens, it goes down and it sucks the water with it. So it's kind of that motion, simultaneous motion of the slide and the water down. But when the water goes down, the next thing, of course, it goes up. And then it floods everything that's here at the shoreline. And this is exactly what happened in Seward in 1964. It's a very tragic story. This is the way, the view of Seward from the space, but also we can see the bottom of Resurrection Bay. So this is the bottom of the bay, and these are the three locations that are all alluvial fans. That, you know, the glacial creeks bring that sediment, and they form those fans. They are very unstable during earthquake. And this is exactly what happened. The entire waterfront of Seward collapsed. And, you know, the remnants of that waterfront is still sitting there on the bottom. You can actually see that. And while the ground was still shaking in Seward, which was like between 3 and 4 minutes, the Seward waterfront, the entire waterfront, slid into the bay within 30 to 45 seconds. And then the largest wave came in about 2 minutes, and the ground was still shaking. This is exactly what happened. And this animation shows you 3 photos of Seward. This is the photo before the tsunami, so with all the docks here. And the next photo will be right after the tsunami. And finally, the most recent satellite image of Seward. Could you click on that? Yeah, you see everything is gone. All the facilities here, all the docks, they are gone, and red line shows how far it was flooded, and look where everything was built again. You probably know that area. This is RV park in Seward. And of course, it's in the inundation zone. Those RVs will be floating debris, like in that video in Japan. Please be aware if you go there. Yeah, unfortunately, they are stuck between the mountain and the sea. They cannot relocate the town how they did with Valdez. They moved the entire town from that potentially dangerous area. In Seward, they couldn't do that. There was no place to move Seward. Now in Southeast Alaska, same thing, the pretty large landslide potential in Southeast Alaska. Guess what? In Skagway in '92, a huge landslide happened, underwater landslide that made a tsunami and killed 1 person and destroyed the dock completely. And that slide was caused by extreme low tide. So this is one of the factors that can cause underwater slides. Sometimes even you don't need the shaking, just extreme low tide. Litui Bay, the world's largest wave, happened here. Tidal inlet here, there was a huge chunk of rock sitting there and slowly moving down. So it's being monitored. We modeled that thing collapsing into the bay, how much the wave can be made. It's a big wave. Just recently, another slump was identified in Lutak Inlet near Haines. I was there with presentation of the tsunami map, and the city manager showed me this line, and he asked me, "Do you see anything?" I said, "No, I don't see anything." He said, "How about like those little things?" He said, "Let me show that to the geologist." The geologist said, "Yes, it's probably a slide." They sent a helicopter there. Indeed, they had identified the cracks. They said that can collapse into the bay. And I'm standing here right at the ferry terminal looking at the slide. So if that happens, the ferry terminal will be gone. Everything will be gone. Tan Fjord, huge wave, 4th largest. And recently, just very recently, they discovered the unstable slope in Barry Arm, which is in Prince William Sound. It made national news because that chunk of stone is huge. If it collapses, it can make about 10-meter wave in Meteor, which is pretty disturbing. So how do we mitigate those hazards in Alaska? We have a component of the National Tsunami Hazard Mitigation Program, and the partners are University of Alaska and Alaska Earthquake Center, where I work, then Division of Homeland Security and Emergency Services in Anchorage, and State of Alaska Division of Geological and Geophysical Surveys. They are our publishers. When we write a tsunami report for a specific community, we send it to them. They send that report to outside reviewers, just like peer review for scientific papers. And then we work on that report, and then when it gets published, we deliver the results to the community. So we start with community needs. We find out what they want us to map in the community. We make tsunami scenarios, calculate everything, then go to the community, deliver the results, ask them if it makes sense for them, if they have any specific requests. Like, for example, in Haines, they wanted us to look at the slide. In other places, they also found areas that haven't been mapped before. And if needed, we go again, along that loop. I started working in that project in 1998. And the first community was Kodiak, and we published that report, I think, in 2000. And since then, we developed several different tsunami products that include maritime guidance for ports and harbors, pedestrian evacuation maps that show how much time a person in any given place in the community needs to get to safety, and if this time is under the time that the first wave comes. And then we had to update several reports with the knowledge that we acquired after the 2011 Tohoku tsunami. We learned a lot of things about underwater sources. And finally, we have that new project, which is the tsunami brochures for coastal Alaska, which are custom-made specifically for the communities. Take a look. And we're working now with Seward, Homer, Kodiak, Sitka, Heidelberg, and Craig. Valdez and Unalaska already done. It was a pilot project, and we are having a very good response from the community. So the goal is to involve the community in the project in such a way that they kind of own that brochure, so they can kind of distribute it in the community. They can educate the public when they participate in the project. So how do we make a tsunami map? So this animation, could you please click on that, shows you how the waves inundated the Kodiak Naval Station in 1964. Just look at the position of the shoreline. So the wave come in and out, and the shoreline moves constantly. And we just record the position of the shoreline over the entire numerical run. And then we just fix it at the furthest extent inland. Then we say, okay, let's look at all other scenarios around the Pacific and calculate the same for each of them. Finally, we take all that stack of the inundation lines and we kind of make an envelope, and we call it the worst case scenario for the mapping. And now I'm so proud that we have those tsunami maps on your phone. If you go to tsunami.alaska.edu on your phone, on your computer, anywhere, could you click on that link? Then we get to our tsunami hazard map interface. And if you travel in coastal Alaska, I highly recommend going there and check the what kind of tsunami map that community has. For example, where do we want to go? Like, what's your favorite community? I find Skagway very interesting because you go to Skagway, you click on the inundation extent and the water depth. And we chose those three colors. Yellow is water depth less than 1 foot, then 1 to 6 feet, which pretty much means human height, and greater than 6 feet. And this is your map. So you can look at the map and you think, okay, maybe I'll stay here rather than here, for example, right, for my little vacation in Skagway. So you know how many tourists come to Skagway from those cruise ships every day, like thousands. And the police chief in Skagway said that we already have a plan how to move them in case of a tsunami, and they have buses here, and those buses will drive them to Canada. So this is the plan to evacuate tourists from, in case of a tsunami, from cruise ships. So how do we get back to? Anyway, yeah, please try it on your phones, that tsunami.alaska.edu, and make sure it works for you. So these are the brochures. It's very kind of general information about tsunami hazard on the outside with some specific contact information for the community. And on the inside, we have a map that has all the important locations and the flooding area. So this is the, we are getting to the conclusions. And the most important thing to remember is that tsunami hazard in Alaska is what we call near field, which means it's pretty close to our shores. And we have active subduction zone, we have glacial fjords, and unfortunately, we live on top of that. People in Alaska, all the communities are placed pretty much on top of subduction zone and glacial fjords. And it's a very unfortunate combination. In 1964, pretty much all the fatalities were caused by local near-field tsunamis. And since we are the largest producer of tsunami in the United States, but have very little time for evacuation, again, knowing what to do rather than waiting for people to tell you what to do, it's the difference between life and death. And this is the most fascinating story I recently discovered. So I had that video for a while. It's the video from a Japanese TV station showing from inside the car, from a dash camera inside the car during that tsunami. And the video goes all the way to the point where the car is floating and the waves are splashing in the windshield. And I always wondered what happened to that person. Did he die? But how they recovered the video? But if he didn't die, how did he get out? So let's look. And also there are several education moments here, as usual. Making the right decision is crucial. So you know that if you are in a coastal area and you feel a very strong earthquake, you have to evacuate immediately, right? You don't wait for people to tell you what to do. But in Japan, citizens are very, very they organize, they trust the authorities, they follow the instructions. And look at what was happening. Yeah. So he's driving here and he stops at this intersection. And you see, this is uphill, this is downhill. And this is when earthquake starts. That person can stand. Look. So this is the ground shaking, right? And guess what? He goes to the left. Instead of going uphill and evacuate immediately, he goes to the coastline. Again, so you see, it means it's very strong earthquake if a person can stand. And now look at that intersection here. It will show you that green circle. You see, there are cars already floating there. And this guy realizes that he needs to get out, but it's too late, because look here. The water comes from here. That's it. So this guy is still sitting in the car, and dash camera is still recording it. Look how quickly everything happens. How quickly water goes up.
そして25秒後には車は完全に浮き上がり、制御を失い漂い始める。この時、室賀さんはまだ車内に留まっていた。
Could you scroll to the end so we look at the it's a long video, and then at the end here, it's like that's it. It splashes into the windshield. Then I was always thinking like, what happened? Fortunately, we have a seismic analyst in our lab. Her name is Ayumi. She is from Japan. So I asked her to tell me like what they're talking about. She said it's pretty much impossible to tell anything from this video. They just commenting on what's happening. But she found a different program that this clip was a part of from Japanese TV. And then in that program, I made a couple of clips from that program, and this is one of them. Could you start it? So this shows you how they did the numerical modeling of that car standing between two streets and how the water came from both sides. Look, the water is coming. So he's looking at this one. The water is coming from back, and now they have that vortex going on. Now the question is, which stream will win, where the car will go, right? You can predict that because you need to do the modeling, and this car is taken that way. Because that street, that flow from that street is stronger. This is how it's like, it's not intuitive. You can't make decisions like that when you are floating in a car. And finally, we found about, no, it's the next one. This one, yeah, could you click on this one? Mm-hmm. This guy survived. Guess what? This is the guy. He somehow got out of the car at the end when the water is already inside the car. And the camera, we have exactly the same Sony camcorder at home. The camera survived. They dried the chip, and they got the video out of the camera. And he found the camera inside his car like several weeks or months later after they recovered the car. So it was quite a story. But again, the educational moment is he came to the intersection, right? And then there is strong ground shaking, and you have a choice of going uphill. He said that he was going to work, and his work was in a coastal area. And since at the time nobody announced any evacuation, he just followed, his way to work. He was just, following directions. Yeah, so this is the final slide. This is the important thing. Knowledge means survival. And if you're at the beach and you feel strong ground shaking, or you see the water going away, or you hear a loud sound from the ocean without any specific reason on a sunny day, something is wrong, and you need to move immediately to higher ground. If you are don't return until all clear. Don't come back after the first wave, because there will be many of them. And not the first wave necessarily. The first wave is not necessarily the largest one. It can be the fourth, it can be the number 12. And you can always follow National Weather Service, National Tsunami Warning Center on messaging system. And if you are in Oregon, Washington, California at the coastline, and you don't see any high ground anywhere, look around and locate a reinforced concrete building like a hotel, and think about how you're going to get there from the beach. This is just so important. Just look around, locate that reinforced concrete building, because these are the only buildings that will stand after the tsunami. And if you're at sea, you know that being in deep ocean is much safer than being in a harbor. Stay there. Stay in deep ocean. Don't get back to the port. Thank you. Thank you so much. Yeah. Questions?
Many people have large trailer RVs, and they sleep right by the water. And these can come at night.
Exactly. Yeah.
They don't have
Yeah.
a chance.
Yeah. Yeah, there should be, like, in the places like Seward, Valdez, they have sirens. If they have a tsunami that was generated by an earthquake, they switch the sirens on. In some communities, they make that decision locally, like in Valdez. In some communities, for example, in the Kenai Peninsula, they have a Kenai Peninsula Borough Emergency Operations Center to push the button and switch the sirens on. Yeah, there are sirens, and we work with communities on installing the sirens, replacing the sirens that don't work, and so on, like upgrading the sirens. Now, you can pretty much record any message, not just the sound. You can actually say, please move to high ground or something like that. Tsunami is coming. Yeah. So yeah, it's a good idea to find information, local information about tsunamis in coastal communities, but at least find the inundation area, find how to get out of that area, and yeah, just be aware of the hazard in that community. Mm-hmm.
Many people think of water as something soft and taking showers in. But when it's in a hose, even a small hose, and you spray, you can feel how much force it has. If a fire hydrant is opened, one can see how much comes out, and much force from just maybe 9, 12 inches. Or these 5-gallon bottles of water, 40 pounds apiece. And if you have a dozen of them and put them on wheels and then push it against some people, they have a better understanding of how just 10 of those, 400 pounds, can push them back rather easily.
Yeah, that would be a good experiment, yeah. Yeah, the force is enormous. I have a photo, sometimes I show that photo from Meteor, Alaska in 1964, a 2x4 wooden plank stuck through the tire, like it cut through the tire. And it just like, think about it, how much force you need to stuck 2x4 through the tire, yes?
Yes, there was a really good article a few years ago in the New Yorker, I believe by
Yes.
Colbert, about the Canadian.
Cascadia subduction zone, yeah, it was an excellent one, yeah.
It was, and my question to you is, have you worked with or do you know of the emergency preparedness on the West Coast?
Of course, yeah. Yeah, we, twice a year we have our National Tsunami Hazard Mitigation Program meetings, and every state has 2 representatives, one from the scientific kind of part and one from the Homeland Security and Emergency Management kind of service. And we have pretty much all Pacific states, all 5 Pacific states in that program, plus Gulf of Mexico and the East Coast states. And yes, Cascadia's subduction zone is a threat. It will happen pretty soon. And unfortunately, many people will be affected there. And state of California, Oregon, and Washington, they already completed their tsunami inundation mapping for the entire state because they have a very different type of maps. You remember, like Oregon coast, it's just a straight line, right? Pretty much everything there, like community after community after community, but it's the straight line, and all the tsunami sources that will affect that area, they are still the same. In Alaska, it's so opposite. So in Alaska, every section of the subduction zone has a different set of tsunami sources. Southeast Alaska has its own thing. The Gulf of Alaska and the Prince William Sound, completely different tectonics. So we need to do like specific tsunami modeling pretty much for every community in Alaska. We can't just do them in bulk like, those states did. And that's why it took us a little longer to go through all that mapping. But, different states have different approaches to tsunami preparedness, and the best one is in Oregon, I think. They just go door to door. They just knock on the door. They have that great grassroots activity, the Tsunami Preparedness kind of group, and they just do so many different education activities, including drills. I think the most important one is a tsunami drill, like when you fire the siren in the middle of the night and people kind of practice evacuation and see what happens. And we did that. I mean, not we, the nature did it for us in Kodiak and in other communities in Alaska when there was an earthquake in the middle of the night, tsunami warning, but fortunately no tsunami, no big tsunami happened. But during the evacuation, people discovered so many problems that they had in the evacuation plans. For example, people evacuated in Kodiak to high school, people brought cats and dogs, like in one gym. It was a disaster. On the Coast Guard base, families were supposed to evacuate to the daycare center. They came to that hill. There was a fence. Nobody knew who had the key from that fence in the middle of the night. So women and children standing there in what, November or January, I don't remember. Like, who has the key? So things like that. While the husbands are lifting helicopters in the air because they have 6 minutes for protocol to lift the helicopters. So there are many, many different things that they discover that needs to be fixed. And that's why I say when you have an evacuation that didn't result in a tsunami in the middle of the night, you don't complain because it's better to be inconvenienced than dead. So this is kind of the message, yeah. Yes?
You gave some examples on the recent Japanese tsunami where their system failed.
Mm-hmm.
But are there any estimates of how many lives it saved? I mean, like you were saying, that there was that building. Yeah, it was, the wall was too short, mm-hmm. But the top floor.
Oh yeah, you're right. Thank you. Many people evacuated. Yes, of course, many people evacuated. Many more than died. Yes, the percentage of people who died was not that large. Yeah. We are not living in a perfect world, but there were so many failures in that tsunami, and one of the most dramatic one was that because of that huge uplift that happened at the trench, the initial earthquake size was underestimated, and that's why the initial tsunami warning message was given for the earthquake of 8.7. And Japanese, they are very organized, and they know exactly what to do for 8.7. They know where the shelters are, and they just get everything, and they keep walking to those shelters. And many of them didn't look again at the phones for updates. And when it was updated to 9.0, it was already too late. They already kind of reached the shelters, and some of them died in those shelters. Yeah, I mean, you could just keep walking, but they thought, okay, 8.7, we know what to do. We are safe here. This is the map. This is the shelter. It's like every time when you have an extra step to do that step, even though you think it's safe. Just, be critical of everything. Not everything, but so, yeah. I have so many more, oh my gosh, so many cool slides I just couldn't fit into,
Is there analogous watching going on the eastern coast of North America? Is anybody worried about tsunami waves there?
Oh, East Coast, there are 3 different possibilities for the East Coast. One is kind of that exotic of the volcanoes, Canary Islands, collapsing into the ocean and generating the wave. Again, we will have time. After that happens, there will be enough of warning time. Second thing is the collapse of the continental shelf, like landslides that happen off the shelf. And the one that happened in Canada in 1912, I think. So it happened before. It's a documented case, and the cable was broken on the ocean floor in the North Atlantic, and also people died in that area. So this is the second thing. And the third would be the Meteor Tsunami, as I mentioned. If we have a storm moving over large surface of water for a while, under right condition, under kind of some resonance condition, it can be a tsunami. So it's a different mechanisms there on the East Coast. They don't have earthquakes there. So. George, do you have any questions? No? Thank you. I so appreciate you coming on such a beautiful day.